every USB charger I kill. Uh-oh. What is beeping? What is beeping? Today, we're going to be making the first ever, as far as I'm aware, the first ever USB-powered microwave. Now, maybe you don't realize how hard this is to actually do, because it's like, yeah, bro, like fucking everything runs on USB now. You run like pretty powerful laptops on USB, and like, you know, you charge basically everything through USB. You can even charge like jump starters and stuff with USB. So that's a pretty like severe amount of power that we're probably able to get from USB nowadays. But none of those are microwaves. Microwave specifically is hard because they draw hundreds and hundreds of watts continuously. It'd be like powering a space heater on a USB power. Also, they are intrinsically an AC device. They run on a big transformer, and that's how you get the voltage necessary to drive the magnetron. That was the word I was looking for. To actually run the magnetron, you need AC power. So even if you get DC input high enough current to run the thing on hundreds and hundreds of watts, you gotta then invert it back to AC. Basically, it's generally just considered that it's not worth dealing with. There are battery-powered microwaves. There's one made by, how do you say it? Makita?
電動工具でトップクラスのシェアを誇るマキタ。
Whatever it is. The Japanese tool brand, they make one where you literally load 2 drill batteries on the back, and it's a little tiny microwave, and it costs $1,000. But other than that, they're generally only reserved for plugging into the wall and running off your AC wall power. Until today, what we're going to do, because there's no way that one single USB dongle can provide enough power for what is required by a microwave. So what I've got here, one is I got a microwave that doesn't use very much power. It's a 700 watt microwave. Literally the lowest power microwave you can maybe possibly find. You can see I've got a giant capacitor bank there. That's going to be to help us even out from the inrush current, because that's going to be pretty severe. And then to the right of that, you can see I've got like a dozen USB power blocks boxed up, and I have many more than that. Basically, we're gonna need multiple outlets. We're gonna need multiple USB ports, all coming together to work as one to provide us with enough current to power this microwave. Now, 1,000 watts using only USB-A adapters, it presents a couple different problems. One of which is that the power that comes out of a USB-A is 5 volts DC. The inverter that I bought, and almost every inverter that you can buy on the market, is designed to run off a car battery because people use them either in their cars to run electronics or to like run their crazy speaker setups. So generally you want to build around a 12 volt DC power setup. And to do that, then you need to take your 5 volts, step it up to 12 volts, which now we need a converter, but also that's going to take another efficiency hit. So it's like, well, shoot, we're going to need even more than 1,000 watts. And 1,000 watts at 20 adapters per 100 watts means we need 200 adapters, which means we would also need 200 outlets to plug them all into. Now, I don't know if you guys have seen it, but I made a while ago a 100 outlet power strip, and it's like the size of this desk. It's huge. And I would need 2 of those to be able to run all the USB-As, and that's assuming that the losses aren't too much from the 5 volt to 12 volt DC step up before going into the 12 volt to 120 volt AC. Anyway, basically, all this technical details to say, we ain't doing it that way. Luckily, with the modern standard, we have USB-C, and USB-C, the way it works is that if you just plug a regular dumb cable that doesn't have any intelligence into a USB-C port, it'll put out that same exact USB-A voltage, 5 volt, 1 amp. But if you have a little USB-C communicator chip that goes through this little handshake when you plug it in, where it goes, "Are you smart?" And then this chip goes, "Ah, yes, I am smart." And then it goes, "Ah, cool, you're smart. How many volts do you want?" And then this thing goes, "Ah, actually, I would like 12 volts, please." And then the connector goes, "Ah, excellent, I can do 12 volts." Because not every connector can do all the different voltages. And then this one goes, "Okay, cool, give me 12 volts." And then it switches the voltage to 12 volts, and then you can get 12 volts straight out of your USB-C. And not only is it 12 volts, it's not 1 amp anymore. It can be a lot of amps, because these suckers go up to like 100 plus watts each. So now instead of needing 20 connectors to get 100 watts, we can squeeze it out of 1. Now, to do this, we're gonna need a lot of connectors still. So I got this little guy here. I'm realizing it's a little out of focus. He's quite small. According to reviews, they get quite warm when you're sinking a full 100 watts through them, but they can take up to 100 watts on this little guy. It's technically not being sunk through the chip, that's just the thing doing the handshake. But you put your toggle, I think it's these two, up, and then that tells it set it to 12 volts. Plug in here to a smart USB, and then it outputs 12 volts on your little terminal block. Now the problem with this guy is that we only have one of them, so I made sure to get a good old supply of quite a few of these boys, so that we have enough to go around. Also, I had to buy all these special adapters that cost so much money. This is such an expensive stream. Now, I could have bought all the same, but I have basically no faith in these no-brand Amazon, AliExpress type USB charging stations, and I just don't trust that they're actually gonna put out the power that they claim they can put out. We got MGRN Pony, a very popular charging brand. Definitely not invented for an AliExpress resell. We have Ryut. We have Oxys. We have a premium charger cable, which is an AQ2C1 black. We have 2 of those. And then this one is actually full of just charging cables, I think. I think this one's just the cables. Because I needed a pretty decent amount of these, and I did not have that many USB-C to C cables in my arsenal already. I noticed that a couple of these are really short, and some of these are really long. So that will be interesting. We got several, we have 20 of these connectors. So generally the idea is we're gonna go through, set all these to 12 volts, wire them all in parallel, hope that there isn't some weird power feedback thing that blows them up. So I'll start with 2 first, because that's pretty important. And then hook all these up to the inverter and see if it works. And if it doesn't work, if it works, then we have innovated in a new field. If it doesn't work, then we cry and run home. Let's see, oh, okay. This actually doesn't have any cable in it. It's 2 charging blocks, which it claims 65 watts, 20 watts, and 18 watts. So 2 65 watt. All right, that's pretty good. Apply this charger for your phone. You can enjoy convenience and freedom in your life. I'm sure I can. All right, we got 130 watt there, another 130 watt here, because I have 4 of these. Now, these are starting to get a little more serious. This is also a 2-pack. 2-pack of chargers. These are like the weight difference between this charger. This is the Unksys. This is the entirely unbranded. It doesn't even have a fake name on it. Versus the Unksys. The Unksys is like very noticeably heavy and weighty. 12 volts at 3 amps. So 65 watts. But it has 2 ports that can do 65 watts. So this basically has 2 of these guys inside of it. And we're not even counting because the other plug on these can do 20 watts. Assuming it's telling the truth, which I'm not gonna lie, I'm a little doubtful whether it's telling the truth. Next up, this guy here. Now, I do find it a little concerning that on the internet, when these are listed, they have the wattage in the title, but on this packaging, wattage is nowhere to be found. If I remember correctly, one of these two, I can't remember which, one of these claims to have 800 watts simultaneous output, which I highly doubt. 800 watts, there's no fucking way it's 800 watts output on any of these. This weighs like it has 4 of these inside of it. Written on the back of this, it claims that all 5 of these can output 12 volts at 3 amps. We'll see. We'll see about that. And then this guy, I think, is probably going to be the same as this. I'm getting it out, and I'm starting to wonder if it is literally the same as this. Because it weighs about the same. Actually, no, this is significantly heavier. Now, I'm not saying these are made in, like, the same factory or anything. But this one only supports 20 volts at 3.5 amps. 12 volts at 3 amps. And then on the first 2, and then on the other 3 USB-Cs, 12 volts at 2.5 amps. It doesn't allow, and that's the highest it allows for any of it. All right, got a red light on this guy. And should get 12 volts out with those settings. If one of them's a different voltage, it's gonna feed back and blow up the power brick, which is not preferred. Okay, this is our cheapest power brick. Let's do a little test. Can I wire them in parallel without blowing anything up? That's the goal. 9 volts? That's not what I have it set to, dog. The fuck you mean 9 volts? Good thing I check them, or it definitely would have fucked something up to plug those into parallel. What about this one? 9 volts? Dog, is this thing, like, labeled wrong? Oh, good lord. The second plug doesn't allow for... It doesn't allow for 12 volts out, so it just gives you 9. Alright, hang on. We gotta plug in 2? Well, we still need to do this experiment, because if this blows something up, then it's gonna blow up even more when we actually get it all, like, wired together. Okay, see, it's 12 volts now, and then if I plug in this other one, it should also be 12 volts. Yeah, it's 12 and 12. Okay. Now, fingers crossed, this does nothing. Just in case, I'm gonna touch it and see if we get any smoke or sparks or anything. Fellas, I think we might be in business. There's still at 12 volts, baby. Let's fucking go. If we end up smoking it, it's over, dog. We don't have that many extras of anything. We're gonna be running it all she's got. I do not need to be buying extras of everything. We are doing fuck it, we ball type rules, and that's that. 1, 2, 3, 4, 5, 6, 7. 6, 7. You guys are actually brain rotted. You guys are actually fucking cooked. It only needs to work for like an hour to get its value. Dog, you think it needs to microwave something once to prove that it's working. That's it. True electrical engineer. It worked once, now get it to market. I'm setting all these up for 12 volt output. The cable is allegedly thick enough to power the highest USB PD output, but I don't know how true that really is. To be fair, you have to have a very high IQ to understand Yuo's lab. To be fair, you have to have a very high IQ to understand the absolute mauled that I go through every time I'm wrong about something live on stream. Dude, these wires are gonna get so fucking hot. This fucking bell wire that I'm running between all of these. It's gonna get, this shit's gonna cook, dude. I don't like how all of these turned on. They're all like slightly less accurate 12 volts. Oh, this one's 5 volts? I'm sorry, the 5th one doesn't do 12? It doesn't. What the fuck? Interesting. All right, 12 volts. This is our expensive one, so we should be getting 12 out of every single one of these. So we have 5 12s, 4 12s, 9, 10, 11, 12, 13, 14, 15, 16, 17. And only 12 plugs. I need to scrounge up 5 more cables. All right. Let's do 2 long cables connected here. Getting this all, like, assembled together, I'm realizing what a fucking mess this whole thing is gonna be to run. Because look at all these damn cables, and this is only like a third of the amount that's gonna actually go into the thing. Let's plug them all in. No smoke, I don't think, and it's 12 volts output. All right, we're looking good. We're looking good so far. Time for the real test, because this is what it actually has to power. Is this big boy power inverter. See if you can take the sauce. Okay. We powered it up. Let's see if we can power anything off of this. Something light. Nothing too hard. Because this will just prove, because this is just this and this right now. So we're not running full tilt. I just kind of want to see what we're capable of. Converting from DC to AC and then immediately back into DC is a notoriously useful thing to do. Okay, we dipped a little bit there, but it's keeping the laptop charged. It's doing fine. So this works. I don't like that the voltage dipped. That's a little concerning. I feel like ultimately we've proven the base concept here functions. And I kind of feel like the only thing left to do is to just fucking send it, right? Like, I don't think there's more tests to be done. I think now we just band enough of these together, go over to the microwave, plug it all in, and see what happens. You absolute buffoons. These are what I was using when I was building my, my Metal Disintegrator 3000 from like a year ago. I have like 8 of these wired in parallel. Oh, the guys in the fucking YouTube comments that are always like, I hate the horn. Can he please get rid of the horn? Unfortunately, I hate that I've accidentally given them their way, but yeah, the horn is broken, so those guys can have their fucking day, I guess, until it gets fixed again. This is a giant capacitor bank, which should help us even out the unpredictability in load changes. The amount of power stored in these capacitors, I hope something doesn't go wrong in an explosive or fire way, because this motherfucker stores a lot of potential energy. Each one of these capacitors is 5,000 microfarads, so there's 16 of them here. So 16 times 5,000, what is that, 80,000 farads? Intentionally try to make it release the magic smoke and disconnect the microwave if you don't want to fry it. The microwave? The microwave won't get fried. The microwave is a free microwave someone threw away and gave me. All the stuff that I would be smoking is like hundreds of dollars of USB shit, which I would prefer to not blow up because I'd like to reuse it. All right. This is my 100 outlet connector. All right, the microwave does still work. Excellent. And it has this funny this temperature reader. I forgot about that. I installed that for when I made it the inverse microwave. I think I'm gonna unplug this so that I don't have exposed wires on the underside of this while I'm prepping the rest of this stuff. But let's see how. Oh, we can wire all this up. All right, and then we'll take the big boy one here. Do you guys see what's going on here? I'm trying to do my best to make this all visible. I see wires, lots of wires. Well, that's just how the setup is. There are, in fact, lots of wires. All right, hang on. Look, I connected the polarities right, okay? Connected the polarities right. Just something I've had some trouble with here recently. Dude, the drill battery PC where I miswired it and it fucking lit on fire and smoked the main converter, that was tragic, okay? I'm not saying I think it's gonna explode, but I'm gonna put my safety glasses on just in case it does. Okay. We brought it up to power. All the lights are on. No smoke. So you can see we have our two big USB power banks there. And then we have a couple more here that are each outputting. And then those go into this, which as you can see is all lit up right now. This big capacitor bank, which should even things out. That goes into the inverter, which is currently off, and then that goes into the microwave. So this is all USB power, no batteries or anything. There is the big capacitor, but it's not a battery. So let's go ahead and flick it on and see if it can just withstand the boost of powering the microwave in an idle state. Okay. It's on. The microwave is on. The microwave is on, but that's not the main test. The real test is, can you microwave something in it? Do I have anything that's like a microwave food? I know you guys, microwave an airbag, microwave a fork. But like, the first test should be done with food, because I don't know, man. It just should. It just should. I realized the perfect one was right in front of us the whole time. Microwave hot dogs, my classic bachelor meal. Alright. We're energized. It only takes like 20 seconds to cook a hot dog in a microwave. Time cook 30 seconds. Fingers crossed, boys. What is beeping? What is beeping? Oh, the power inverter! The voltage is dropping! It's pulled down to 10 volts! It's trying its best! It's trying its fucking best. Okay, so it didn't shut off or anything. It was just giving a little warning. Now, did it heat this at all? Yeah, it did. It's like it's Okay, so, it went in cold and it came out lukewarm. But, like, it is not nearly as cooked as it should be. So it's clear that the microwave is not getting the amount of power that it's supposed to get, right? Oh, no. Let's move this guy back to the table and get an extra row of USB connectors on it. We need more USB. Bro undervolted his microwave. Well, it's more that the massive amount of current draw made the converters here drop their voltage. Because typically when you overdraw from a circuit, what it tends to do, if it doesn't have something that just shuts it off cold turkey, is it chokes the voltage down. I've added 6 more USB ports. Hopefully that's enough to reduce the dropout and get us just a little bit more power. But I mean, we already have successfully microwaved something. It just like was really weakly microwaved. I want to get, I don't know how much of that it would take to get the thing like steaming hot, which is kind of the is kind of the goal if I can set any at all. So many USB plugs to plug in. We have a couple more outlets we could use if I just had the cables. But I don't have enough USB-C cables to plug them all up. Alright, that's off. Let's plug in the big power strip. See how we go. Okay, all the lights are on. Excellent. Fingers crossed. Okay. Now, I already had the microwave. I already had a hot dog in here. Cold, room temp. It's colder than room temp. I don't know why it can do that. But let's see how this works. Okay. It's pulling. It's throwing the warning on the power inverter. It's gone down to 10 volts, but it's still kicking. It's still doing it. No fire yet. Don't be saying fire. It's trying its best, okay? It's trying its best. Let's see if it's... I'm realizing the plate is like moving slower too. No, it's still moving. I can see it in there. The light is pretty dim though. Alright, let's see. Dude, it's hot! It's hot! It's a hot dog! That actually cooked it! Hang on, wait, 30 more seconds and it's gonna be like, it should be steaming. Let's give it a full other minute, actually. Dude, I can't, it's working! I can't believe this is working. I thought this thing wouldn't be able to get the temp at all. I was really thinking that it just would not be able to make it hot. I was afraid that it wouldn't be capable of it. Right on fucking every USB charger that I can get a hold of. Alright, man. Uh-oh. Uh-oh. Ooh, that's warm. Ooh, those are warm. Uh-oh. That's like steaming hot, dude. Dude, look at the glisten on that glizz. Oh, baby. Take a bite. Mmm. Mmm. Dude, that cooked the damn dog. That actually cooked him. There. 122 degrees Fahrenheit. It's a hot dog. I'm not fucking around, I promise. Okay, so wait, why did it shut off though? That has me a little worried. Is it hang on, can it recover? Okay, I think it can recover. I suppose that it's not very visually interesting to just be like, look dude, it cooked a hot dog. I'd like these to be able to do another little experiment. I'm going through my really old CD, DVD stash. The cool thing about these things is you can see on the disc if someone had written to it or not, because it shows up. Let's see if this will do it. Did you see it start to do it, and then it fucking shut it off? Alright, hang on. And why wasn't able to heat the hot dog, bro? Can you see it? Can you see it? That's all we're gonna get for that, I guess. It's got enough electricity in it to microwave a hot dog, which would normally take 30 seconds over the course of a minute and a half. Really, if you wanted to get to where it was like steaming, you probably need to run it for 2 minutes. It dipped the current too much and it shut the inverter off. I didn't blow the breaker. Alright, see, look, it did the thing it does to CDs. CDs what, you may ask? Look, you made the burn marks. That's cool. Alright, that's a fridge cold dog. Throw that in there. Now if it fails again, then that means that I have somehow fucked up this circuit. And it's just not putting out the current that it was before. No, it's able to heat hot dogs, apparently. But the CD produces too much current or some shit. It's going nutty. It's beeping like crazy. Keep in mind, this needs to be at 12 volts. I don't know if you can see that. It's at 10. That's why it's beeping. 9.9. It's dipping down because this capacitor array is with all the USB plugs on it. It's starting to drop out. It's not getting enough power. And it cuts it off when it drops below, like, 9 or something. Warm hot dog? Nice. Let's give us another minute. Let's see if we can get it to where it's, like, splitting and hot. Or if it's gonna cut off again, like it did last time. Ah, there it goes. Come on, man. We need you on your best behavior. Let's see if it shuts off real fast again. It immediately, when you turn it on, the voltage starts dipping and it starts beeping. It's around the same time, like 15 seconds. We're microwaving this hot dog in 15-second intervals. Okay. Let's see if it's visibly hot. I mean, it's hot, but it's not visibly hot. The hot dog is like the only thing that you can cook properly, man. 120 degrees, or 119.5. Ah, the hot dog test is it's the only thing that can actually cook it right. Well, the test is replicable. It only microwaves hot dogs, I guess. Don't know why that is. Aye, aye. It was struggling, but it barely did it, but it did heat up the hot dog. Here in the industry, we call that mission success, though.